We're going to review the GAST Air Compressor. The purpose of the air compressor is to replace CO2 to operate our bag-in-a-box pumps. So we can use compressed air to power our pumps, which will save in the reduction of CO2 usage. We're going to start off with the motor and pump assembly. This is a 115 volt AC motor. The motor operates the pump compressing the air. The pump and motor are a pair or assembly. If either the motor or the pump should fail, they're replaced together. We have a filter. This is a 0.3 micron filter. It's replaced yearly. That compressed air coming out of the motor then travels through the high temperature hose. When the pump is building pressure and compressing it, the temperature is a lot higher, so it needs to be a high pressure, high temperature hose. We then have a pressure switch. This switching device turns on and off our motor to operate the pump to build more pressurized air. We have a gauge. This displays how much pressure is in the air tank. To power this compressor, we need a 115 volt AC, 15 amp outlet. The outlet has to be within 3 feet of the air compressor. The tank, this is where we store the pressurized air. We have a manifold. It's where the compressed air from the pump is pushed inside the accumulator tank. It's also where the pressurized air comes out of the tank. We have a check valve. This prevents any pressurized air in the tank from traveling back to the pump. The air outlet, this is where the pressurized air from the tank is pushed out. We use a 1/4 inch line. It goes downstream out of our air compressor and feeding a regulator to the bag-in-a-box pumps. For safety, we have a relief valve. This is set at 130 psi. So if the tank overpressurizes, it will release out of the relief valve. We have a drain. This is where we can drain any water out of the tank. Remember, when we're pressurizing air, that moisture can collect inside the accumulator tank. So it's a requirement. Once a week, we need to open up the drain to drain out any water. In humid climates, you may have to do this more than weekly. Eventually, if the tank fills completely with water, you cannot store any pressurized air in the tank. On this air compressor, we want the motor to turn on at 75 psi and turn off at 95 psi. Plug in the air compressor and allow to run. Check to see where the switch is cutting off. To access the pressure switch adjustment screws, remove the pressure switch cover. Under the cover, we have a set of contactors. When the contactor is in the open position, the switch is open, no current is sent to the motor. When the contactor is in the closed position, the switch is closed, allowing power to the motor. By adjusting the tension on the spring, we are setting what pressure the switch will close to allow motor and pump to build pressure in the tank. We see 2 adjustment springs. The large spring is to set the differential. The smaller spring is to adjust the range. The differential is where the contactors open and close, or motor runs and stops. We want this air compressor to turn on when the pressure falls to 75 psi. We want it to run and turn on and build pressure, turning off at 95 psi. This 20 psi is the differential. By adjusting spring tension, we can move that differential up or down, as you can see illustrated to the left. The smaller spring is the adjustment for setting the range. A new pressure switch is set with a range of 20 psi. By turning the smaller spring clockwise or counterclockwise, this range can be adjusted. We always want the range to be 20 psi. If the range is not set to 20, you can run the motor and verify and make adjustments by turning the small screw clockwise or counterclockwise. Remember, we want the motor to turn on at 75 psi and turn off at 95 psi. To verify where the air compressor is turning on and off, with the compressor plugged in, use the drain valve to slowly release the pressurized air from the tank. Monitor your gauge and see where the motor turns on and where it turns off. If we are not at the differential, 75 to 95 psi, we must adjust the pressure switch. Adjusting the pressure switch. Step 1, unplug the compressor from the wall outlet. Step 2, slowly open the drain valve and release air from the tank. Close the drain when the gauge reads 75 psi. Step 3, look at the contactors. Are the contactors in the open or closed position? In this example, the contactors are open. If the contactors are open, turn the large adjustment spring nut clockwise until the pressure switch snaps closed. Step 5, plug in the air compressor into the wall outlet. Allow the motor to run. Monitor your gauge. If the range is set correctly, the switch will open and the motor will stop at 95 psi. The switch is now set to turn on at 75 psi and to stop at 95 psi. You may have a situation where the switch is already closed and you need to perform an additional step. Let's review. Step 1, unplug the compressor from the wall outlet. Step 2, slowly open the drain valve and release air from the tank. Close the drain when the gauge reads 75 psi. Step 3, look at the contactors. Are the contactors in the open or closed position? In this example, the contactors are closed. Step 4, if the contactors are closed, we need to reset the switch. Turn the large adjustment spring nut counterclockwise until it snaps open. Once open, we're going to turn the adjustment clockwise until it snaps closed. We want the contactor to snap closed at 75 psi. Step 5, plug in the air compressor into the wall outlet. Allow the motor to run. If the range is set correctly, the switch will open and the motor will stop at 95 psi. The switch is now set to turn on at 75 psi and to stop at 95 psi. This is how to adjust a pressure switch on an air compressor.